Hey everybody, it's Cameron B with DevFacto here again, and today I want to give you guys an introduction to MVVM. MVVM stands for Model, View, ViewModel, which, maybe not the best name, but, regardless, it is a pattern that's used to kind of help solve some of your UI problems. So you're going to use this a lot in WPF, Silverlight, Windows Phone 7. You can use it in all sorts of other stuff, but those three kind of areas are going to be really applicable to today's topic. Okay, so just a quick overview of what's going on. I'm just going to fly over the MVVM landscape, chart out our course. Then I'm going to go ahead, we're going to talk about some MVVM and how it relates to your .NET stuff. We'll go over, we're going to talk about our first view model, making your first view model. Then we're going to get our view on, and that just means we're going to talk about the view, and then we're going to go through a demo after that, and once that's done, I'll give you some tools that you can check out when you want to scale your application out and make things easier on yourself, as well some examples of MVVM other places and other technologies, other stacks, etc. Okay, so let's just get started. Okay, well, MVVM, why are we even here? I mean, that's going to be a big question. Well, there's always the old way and there's the new way. So the old way, we're talking WinForms, we're talking ASP.NET, we're building UIs, right? And so we had this great idea, let's have this UI code and this UI declarative stuff. So you would have like a designer file or some markup, and you would usually have like some sort of code, right? And so what you would do is you would throw everything together and you would code against your objects, against your UI, and it was amazing. I mean, you could do everything, right? However, obviously, things get old, go the way of the dinosaurs. It's got to improve. So what were some of the things that were wrong with the last generation? Well, when you're talking MVVM, by the next generation, the last generation, whatnot, it was your WinForms, and your WinForms and your ASP.NET had a problem with huge UIs. So the UI traditionally was, just to show results and accept some input, and all of a sudden, now we have all this code in there, and code to help produce the effects that we want, right? So sliding, fading, zooming in and out, flying around the screen, all that stuff, done through code. In the same place that you're doing your validation, and in the same place that you're just putting information where it needs to go, right? Certain stuff into the right boxes. So we kind of have all this code and a lot of responsibilities that were moved towards our UI, right? Now, I mean, it made sense when everything moved towards our UI because, clients were getting better. We didn't need these gigantic servers to process all this data. We were able to move everything towards the UI. And once the UI, once it was on the UI, it was on the client machines, for example, in ASP.NET, for example. We could do amazing things with it. But it's starting to kind of become old. So let's, move on to the next thing. Okay, so the view. We've got this M, we've got this V, and we've got this VM. What do they mean? Well, one of the V's, the first one to be specific, stands for view. And so with the view, the best thing that I've found when I'm implementing my projects, and specifically I'm looking at a project that I did for a job tracking system. But when I did that project, I found that the best way to think about the view is back to basics. When we, at least when I was still in school, UI meant accept input, display results. So it was always this back and forth, and your UI was just the last boundary between you and your user, right? And that's all it was, right? We were told that's all it is. That's the only thing that the UI should be doing is accepting input and displaying results. However, as things need to become more intuitive and whatnot, we moved a lot of our validation to the client side, right? For a better user experience. We started zooming things in and out. It wasn't just a console that we were talking about. So all of a sudden, we kind of didn't know where to put this, so we shoved it all in the UI, and it just became a huge mess. So when you're thinking in MVVM about the view, think back to basics. Next, the last two letters, VM, that stands for ViewModel. So the view model. Well, if the view is accepting input and displaying results, right? Where's the logic? Where's the validation? Well, that all belongs in your view model. So your view model I like to think of as your brain, the brain of your operation. And just like a brain, it has a receptor. I mean, a brain has several receptors, but we're talking about kind of one receptor here. And the idea behind the neural receptor analogy is this, is that your view and your view model kind of fit together, right? You can pull them apart, just like you can pull apart two neural receptors, right? They aren't linked together. That you can pull them apart, and you can stick them with any other receptor, as long as the kind of pattern fits, I guess. As long as they mesh. There's going to be a part in all of these that is exposed, and has to mesh with another exposed part. I'm sure it'll make a lot more sense once we get into demos and everything like that, but that's just kind of like the concept behind that. And then there's the model, and I just kind of figure the model is everything else. Now, when you're talking about some of your really basic MVVM examples, you find on the net or whatever, they'll go over, oh, this is how you make a view model and a view, and this is your model. And typically in those, I found that you have your model class, right, which is sometimes a data model, and it has the information to persist. Your data changes, and I always found that was kind of the most confusing part about getting started, was that the model doesn't actually have to be a model. It doesn't have to have the information to persist. It just has to know where to go. So, looking back on it, I kind of look at the model as everything else. And when I mean everything else, I mean that if you are architecting your application with several different layers, your model you would just swap out for everything else. And again, we'll kind of hope to make sense of this. Now, we have the three parts, the MVVM. We have all the letters there. The view and the model don't see each other. And that was kind of the great thing about MVVM, is that you're taking your data and how to store it and everything like that, and you're pulling it away from your view. Because really what would end up happening a lot of times is that we would have data persistence in our view code, right? And it was just kind of too much in one place. So we're kind of hoping to pull that out. Let's not have the view worry about at all how to store this data. So you can kind of think of it like this. The view and the view model talk to each other. The view model and the model talk to each other. But no, the view and the model don't really talk to each other. As well, when we're talking about MVVM, we're going fairly specific. Martin Fowler split MVVM into two kind of camps. Now, the reason that he did this was because MVVM, MVC, MVP, these are all names for the same thing. The same thing, which is this dissociation between the view code, actually, rendering the view, the logic behind it, and how to persist that data. And so when he was when a lot of this MVVM stuff was coming out, people kind of got it confused, and there was a lot of confusion over what's MVVM. And so he said, well, hey, I'm going to split this out. I'm going to make it real easy for you. There's two types. So there's passive. Now, passive is where you have a view, and it attaches onto a view model, right? It binds to a view model. That view model is going to be expected to expose certain properties, and the view binds to it. The view will simply just react to what's going on in the view model. So kind of dumb. Your view is really dumb. It is just passing data back and reacting, right? It doesn't actually do a whole lot. Now, in supervising controller, and I mean, I'm not an expert on this, but from what I read off the net, supervising controller is actually going to take your view and your model and bind them together, and then facilitate just changing the data between the two. Now, I'm not really sure how it all works, but somehow it does. So those are the two types, and really the only point that I wanted to make here is that we're just going to use a passive MVVM pattern. So, I'm sorry if this isn't, if you did your research and you were hoping to see supervising controller, or maybe you're used to supervising controller, but that's just hopefully help avoid any confusion. And, again, the model is hidden from the view. It's very, very important. Okay, so we've kind of gone over a high-level overview of MVVM, but, it can be sometimes important to note which technologies you're using it with, because it depends on your implementation. It's going to affect your implementation. Okay, so the first thing, when we're dealing with the Microsoft stack and implementing MVVM, it's all possible, well, not all possible, but a large part of it is possible due to this idea of data binding. Now, if you're not familiar with data binding, what data binding does is it allows you to say, hey, I'm a view element. So let's say I'm a label. right? Now we want that label to change. Let's say it's a status message of some sort. WinForms, ASP, .NET, what we would do in those technologies is we would say, oh, well, in my code behind, I'm going to maybe check an exception or check the database or something like that, and I'm going to have a result. And I want to display that result to the user. It's no good sitting in a member field, so I'm going to set label1.text is equal to my message. And every time that I wanted that status message to change, I would have to run that line of code, right? If I needed to update it in 3 places, I would have to have run 3 lines of code. And so it's kind of a pain in the butt, because really what am I doing? I'm just taking this label, which is meant to display text, and I'm saying, well, here's your text over and over and over again. I have to constantly tell it what its text is. So what data binding did is the guys over at Microsoft baked it into WPF, and they said, okay, well, here's what we're going to do. We're going to let you be a view element. We're going to let you be your label, and we're going to let the programmer tell you what value you're displaying. So let's say I have on my view model just an exposed string called status message, right? As a view element, I'm going to go ahead and I'm just going to data bind to that. Now we can see that even apart from WPF's MVVM implementation. If you're just building a WPF view, with the code behind it and everything like that, you can just bind. You can just data bind. And so the idea is that when the source of the data, that property, that string, changes, all I want to be able to do is just tell everybody, hey guys, this string changed. And everybody else who is looking at that string and whose data is based on that string is going to say, oh, well, that's really interesting. I'm just going to pull that value again. So it's like an automatic, easy way to refresh your data. And we'll see this a little bit later when we go into our view model, but that's kind of the idea behind data binding, is that instead of having to constantly tell the label to refresh itself and giving it its data, point it to where its data is always going to be, and then just tell it when to refresh, tell it when to pull that data again. As well, data binding will allow you to do it the other way. For example, if let's say you're a view element and there's an exposed string, but maybe this time you're a text box, we can say, hey, every time that you change, push your data back into the value that you're sitting on top of. So let's say it's that string exposed property, you just push down to that string. Now your view model can detect the change and react. So everybody gets to kind of see what data is being changed and subscribe to whatever events they want. We'll see it later. The iNotify property change, that is the interface that takes care of all this data binding. So sometimes we're abbreviated as INPC. This whole data binding thing is done through the implementation of an interface. And so it's going to have, an event that you have to, that you have to implement and whatnot. As well, when you're talking .NET, observable collection of T. Now, it's a generic collection based off IEnumerable. And so what this one is going to do, this collection, is meant to be data bound to a view element, let's say a data grid, for example, to display a list of objects. And every time that collection is changed, it's going to also fire off a collection changed event. And so you, as a view element, you can subscribe to it, or people can subscribe to it, and constantly get these updates. Now, one thing important, kind of important and kind of nifty with all this data binding is that when you're a view element, you don't actually have to, do a bunch of code to subscribe to these events. As long as the target supports iNotify property change, as long as it implements it, or it's an observable collection, the view WPF will automatically subscribe you to those events. So it makes it a lot easier for us to wire stuff up. Okay, so let's start with our view model. Now, we're going to have a demo soon. I just want to get through this stuff, and then we'll get to the fun part. Okay, so you're setting out to make your first view model. Good for you. Okay, we're going to start with the brains, and then we're going to move on. Okay, so the first thing we have to do with our view model is expose some properties for output, also for input, but mostly, for output. And so what we're going to do is make a class, basically, and expose some public properties. That's about all you need to do. Now, to get in with the kind of the mindset of this, you might expose a status message, right? And in your view model, you might constantly pull the database. In order to notify your view of what's going on, all you have to do is just change the status and raise the event, the status message and raise the event. So that's kind of what we're going to end up doing on the view model. It's nothing, no view code at all, just all straight, C#. Now that's great for output, but for input we're going to use commanding. And now what commands are basically snippets of code with a little bit of a wrapper around them. So a command has a .execute method. It also has a .CanExecute property. And so that CanExecute is actually going to is going to be like an indicator of whether or not this is allowed to be run. So for example, if your form's not validating, you might want to put that in your commanding code. And we'll see it later. A command is basically an object that you can use, but you can bind to it in your view to handle your events. And it's a really nifty way of basically running code without having to actually put the code into the view. We're using the passive MVVM pattern here, and this is going to make testing a lot easier for us. That's typically why you're going to want to use the passive. Okay, so I mean, your view model is fairly easy when it comes to this kind of stuff. In fact, the whole thing's kind of easy, but I would say the view model is one of the easiest things. The view, getting everything to kind of bind, is a little bit, just takes a little bit more practice. So with our view, we're going to bind to our exposed properties and our commands. So everything that's exposed off that view model, we want to just bind to that. When we're talking style, resourcing, like resources, or even behaviors, we do this all in the view. So this is where we're going to kind of be at. Now in WPF, you can define your styles in several different resource files, which makes it really easy to break things up and organize your styles very, very easily. But your view is also where you're going to have your behaviors. So for example, let's say you say, when I click that button, it should fade out after I click it, or something along those lines. You will actually go into your view code, which in this case is declarative. This is XAML, and you can actually define just behaviors in XAML of how things should work. So you can define all of your UI code basically declaratively, which makes it really easy to debug and figure out what's wrong. But that's going to kind of be what's going on in your view. As well, and this is the really neat thing that I was not expecting from MVVM, is that it allows two workflows. Now, when I mean two workflows, I'll give you scenario A, scenario B, and scenario C here. So scenario A, you are using old WinForms or ASP.NET. In this case, let's say ASP.NET. You're going to develop your application. Now, in this case, we're going to start with our designer, right? We're going to say, hey, designer, make us a great UI. And your designer is going to go off, he's going to make a great UI. He's going to come back and he's going to say, here you go. Here's all your CSS style sheets, and here's this sample page that I mocked up. So you as a developer, what you're going to do is you're going to take the structure of that page and you're going to try to mimic it in your code. But we'd all love a great, clean UI, but it hardly ever works out like that. And so what you as a developer have to do is you have to kind of force ASP's generated HTML into this structure that your UI guy has made for you. And your UI, you're sitting there, you're going, man, this UI guy does not know what it takes to actually develop against UI, or he would have made this, a lot easier for me. So you're sitting there and you're frustrated with the developer because it feels like he doesn't really know what he's doing. And you're having to make all these concessions and change stuff, and it's just a big back and forth. So scenario B. You are given the task to make a classic ASP.NET web application. So you make your application, and then you hand it off to your designer to do his magic with, right? Comes back with this great UI. But this designer, and I'm sure a lot of the designers feel the same way, is, oh man, well, why can't these developer guys create a freaking UI, right? Create this UI properly for me. And why don't they know how to actually follow standards and how to make divs and whatnot? So your designer, he's getting frustrated after the fact. Now notice in both these scenarios, somebody's getting frustrated, and that's kind of a best case scenario. Somebody just gets frustrated. As well, we also notice that one has to go after the other. They can't do it at the same time. With MVVM and WPF, you can actually do both of them at the same time, and with relatively little frustration. And the idea is this: if you had two software teams working together and they had to interop, they had to do some sort of interop, like interop interoperability, sorry, between the two of them, you would sit down with both teams, right, or at least somebody from both teams, and you would sit down and you would design an interface. This is how, this is how we'll send you input, and this is how you'll give us back data, and you devise this great way to communicate with each other, and then you guys go off, you build against that interface, that common interface, and now you're done, right? Nobody has to wait for the other. You take the same idea, apply it to this. So what you do is on your view, you can actually mock out your view model with all the properties that you guys have decided as what's going to be available. And now your designer can go off and he can put this fake data in and populate with fake variables and fake data and create this great UI that works really well. And you can do that using Blend. At the same time, your developer can go off, he can take Visual Studio, make a real quick and dirty UI that isn't really fancy at all, flesh out his view model, make that really work and pop, right? And when the two of you come together, and I watched this at a Microsoft conference, you'd literally take the one file, the big view file from your designer, you overwrite the developer view, and boom, everything works. You might have to tweak it a little bit, but for the most part, everything just works because you've decided on the interface beforehand. So it's a really great way to get these two workflows working together and reduce the amount of frustration. Now, views are hard to test, and that is, fairly well known. And so the great thing about this, as well with your logic away from your view, is that your view is declarative. You don't need to test it. It's all laid out for you. You just test your VM, how it responds to user input, but you can fake it just by setting a property or executing a command. The actual logic itself is embedded in the view model and makes it a pleasure to test. It's really, really slick. And, you aren't chasing around bugs in your UI because it's all declarative. Okay, so now, enough talking. We want to get to the good stuff. Let's do a demo. Okay, so we've loaded up Visual Studio, and now it's time for the fun part. Let's actually get our hands dirty. Let's get in there. So this is a solution that I've used before in a couple other presentations. However, I just kind of removed all the stuff from the previous demos and whatnot, just because it was going to kind of get in the way. So we have a WPF project in our solution here. Standard WPF application, nothing fancy with this. We also have a unit testing project. It's very important to unit test, so we have our unit tests for this, and they do pass. We'll just run them really quickly. Okay, so they pass. So we're good to go. It's fairly simple. Okay, so let's head into the WPF application. The first thing that I think we should do is just go ahead. We'll take a look at the app XAML here. Now, if you've worked with WPF at all, this is fairly, it's a little file in your WPF application, and it just gives you your startup URI right here. And you'll notice that we're actually pointing towards a XAML file inside the view folder. This is where all of our views are stored. That is actually one of our views. So you can kind of just see that you don't really need to do a whole lot in order to get started with MVVM. When you start from the ground floor, you just kind of start with it. Nothing fancy that you have to do. Okay, so we're, take a look at our view model here. Now our view model, this is the brains of the operation, if you will. So let's collapse some of this stuff here, and maybe I'll just go over it really quickly. So we have here a two public strings. One's called message to display, the other one called input to receive. So these are these exposed properties that I was talking about earlier in the presentation. These are what we're going to have our view bind to. As well, you can see that we implemented iNotify property changed. So down here in this region, I have some iNotify property changed. Now this right here is what's required to actually implement that interface. However, when you're talking about some of the frameworks that are used, and I'll talk about those frameworks later, but when you take a look at some of the frameworks that are used, and just some of the stuff that you find online, this is actually a fairly standard piece of code that you'll find people using and suggesting that you use. And all this does is it just makes it a little bit easier for you to just fire off this event. It's going to be fairly popular. You can even put this into a base class if you want to put all your view models in there. To use a base class for all your view models, you could throw this raise property changed into there. In fact, the whole IMPC implementation. So there's nothing too crazy there. We talked about iNotify property changed earlier, so it should be fairly straightforward. Okay, so we've got these two, these two properties. Let's take a look at the input to receive and the message to display. So the first thing we'll do is we'll talk about the message to display. Now, message to display, basically what this does is it takes the input to receive and it just lets you know, hey, this is what you typed. Input to receive is going to be kind of some input from our application. So remember that the view handles input and displays results. So this will be the input that we're going to use for this specific demo. So when we have a view that passes in a value that the user has typed to input to receive, it's going to store it into this member field, and then it's going to raise the property changed for itself. It's also going to raise the property change for message to display. Now the reason that we're doing that is because message to display actually relies on the value of input to receive. So what we can do is we can say, well, anytime the input to receive is changed, change all the things that rely upon it. So this is something that we kind of have to do manually. However, it's only a single line in this case, but it's something that you can kind of pepper throughout your application to refresh exactly when you want it to. For example, if you have a list of materials and you have a total property that inspects that list of materials and provides a total, well, when you change the materials, you're probably going to want to change that total. So it kind of allows you to choose when stuff refreshes. So message to display, if you haven't already taken a look at this, basically what it's going to do is it's going to check input to receive. If it's null, if we haven't entered anything yet, then it's just going to let us know that we haven't done so. And if we have entered something, well, it's just going to tell us what we typed. Fairly simple, straightforward stuff. So that's kind of how this works. You set input to receive, and message to display changes. Input, output. So we're going to go ahead, we're going to move over to the view now. We're going to see how this works. Now this is a standard view. And this view is just a window class, and you can use anything that you want to. You can use a text box, you can use a text block, you can use user controls. I prefer to use user controls instead of windows to help break things up, but I mean that's completely up to you. But in this case we've said, well, our view is going to be a window. And right here we're actually going to set our data context for this entire window to be a new instance of our view model. So when our view model starts up, if we go back to it here, it's going to start up. We have no no special constructors or anything like that. It's going to start up, and what our view is going to do is it's going to attach onto our properties. So over here we have a text blocks, and the text block has a text property which is being bound to message to display. Now, if you don't really know anything, if you haven't really used WPF and you don't know about the data context, it's fairly simple. Your data context is just a class or an object that provides basically data to your, I guess, to your form, or your control, or whatever you're looking for. It's not just a piece of data. It's not just a single list. It can be several different things. And so we call it a data context because it's not just a single piece of data or a list of data. It could be several lists of data. So it's an entire world of data that you can kind of connect to. So we can see here that we are displaying a text block with the message to display property. The other thing here that we have, the text box. Now it's binding to input to receive. And the mode is two-way. So with a two-way WPF binding, what it means is that if the source changes, and the source in this case is the property on our view model, if that changes, we'll go ahead and display that in the update the UI. So that's where we get into these raise property changed events. This is the mode two-way tells the binding, hey, you know what, you should go subscribe to the property changed event. And the other thing that we have here is update source trigger. Now, update source trigger in this case is set to property change. Now, there's several different ones that you can use, and actually I'll bring up a list here. There's default, explicit, lost focus, and property changed. Default is going to end up being default, which unfortunately depends on the property that you're binding to. For everything, it is a lost focus, I believe, except when you're binding to a text property of something else, then I believe it's a property changed. But I'm not 100% sure on those. That's just off the top of my head. Explicit. Explicit is, well, you know, I mean, it's kind of self-explanatory in a way. It just means explicit. It means that you actually have to tell the text box, hey, you should update your triggers, update your sources. So you should refresh, pull those values again. Lost focus is going to happen when we lose focus from the control. It's going to go ahead and it's going to update. So in this case, it would not be putting the value into the property, the exposed property, until we lose focus from the control. And property change was the one that we're going to be using. Basically says any time that the value changes, go ahead and just update the source. So what's going on here is that we have a text box. We've bound the text to the input to receive, which means now that anytime that we type something into the text box, because the mode is two-way, it's going to update the exposed property with the new value. And because our update source trigger is property changed, it's actually going to do that every time the value changes, which is every time that we type a letter. So we're going to see very, very easily this binding and this constant UI refresh. So just before we run it, basic idea of this view is we're going to display some text with a message about what we've typed. We're binding our data context to a copy of this view model that we've created, which implements iNotify property changed, allowing us to update our UI whenever we have changes in our properties. Our input to receive is going to store what we're typing, and message to display is simply going to display the result of what input to receive is, whether or not it's null or whether it actually has a value. Okay, so our unit test run, we're good to go. Let's run this application and take a look at what it does. Okay, so up at the top it says you didn't type anything yet. We'll go back here, when it's null, that's what it should be displaying. So now I'm going to type a letter and we're going to see our first property change notification kind of happen. Okay, so we can kind of see right away, immediately I typed, I didn't press enter, I didn't tab out, I didn't have to click anything, it just happened. So I can type, and there we go. Fairly straightforward. Okay, so all well and great, we have our basic view and our basic view model. However, the one thing that we have not done yet is accepted any sort of input in terms of events. So what I want to do right now is I want to show you guys how to implement commanding. Now, commanding, when I was starting out and first learning about MVVM, especially when I wasn't using any of the frameworks, commanding was one of the most difficult things to kind of understand. So I just wanted to make a basic command and show you guys how it's done, because I have not seen a video on how to make a command that is not 40 minutes long and goes over way too much. So a command, like we were talking before, it has execute method and a CanExecute property. So what we want to do is we want to make a command and we want to expose it on our view model and bind to it from our view. So the way that we're going to do this is we're going to make a command. However, there's two commands that kind of come with WPF. That's routed command and some other routed UI command. However, neither of those really do anything on their own. They're kind of just there for other implementations, I'm sure, but I've never been able to figure out why they're there. However, there is a really cool interface called iCommand, and iCommand is going to allow the view to bind to us. So it's not actually binding to just any object as a command, it has to bind to an iCommand. So we're going to create an object. So we're going to go ahead and we're going to make a command that runs a snippet of code. And in this case, we're going to probably want to set that snippet of code as an action. So we're going to call it an action command. And it's going to implement the iCommand interface. Okay, so we're going to just use ReSharper here to generate our 3 implementations. Okay, so the execute, the CanExecute, and the CanExecute changed event handler. So this here is an event, sorry, not an event handler, an event, CanExecute change. So buttons will subscribe to this, and objects that support binding to commands will probably subscribe to this event to know when it's allowed to execute. Fairly simple. CanExecute. Now this is a property, essentially a get-only property on the object that will return whether or not the command is allowed to execute. So for example, if you have a bunch of validation to do and you want to say, hey, you can't save until you validate properly, deal with that in here, and all of a sudden your button will turn on and off, kind of enable and disable itself based simply on how the underlying code is reacting. So there's no need to do it explicitly, you just have to define when it's active or not. However, in this case, we're going to not worry about that, we're just going to return true. Now execute. Now execute, here's where we want our code. However, because we're in a different class, we can't really add code here from our main class. It can't reference any of these other variables. So what we're going to do instead is we're going to create a custom constructor. And we're going to ask for an action. We'll put it into a member field here, and we'll store it in the constructor. Now, in our execute, we say, well, when we execute this, go ahead and execute with what we want. Okay, so there we go. We've gone ahead and we've just created a small action command. Now you can put all sorts of logic into these commands, which makes them really powerful, especially if you have several different actions that are very complex but are kind of the same. You could create one big command that you could use across multiple views. However, here we're just going to use the one. So let's go ahead, let's expose a command. So the first thing that we're going to do, we're going to expose an I command, and we're going to call it click command. We're going to make it an auto property. We're going to give it a backing field, and this allows us to kind of just generates our getters and setters mostly. And I mean, you could create a snippet really easily to go ahead and just handle this entire creation of properties. So there we go, there's our click command. What we're going to do is we're also going to create a constructor. And in the constructor we're just going to say click command. And we're going to say it's a new action command. Okay, so the code that we want to execute, well, what we can do is maybe let's just change that input text to show how it all works underneath. And so what we're going to do is we're going to go ahead and we're going to say that input to receive is equal to hey, it works. Okay? So we've made a command that takes some code to execute. When the command itself is executed, it runs our custom snippet of code that we've stored up here. Now, the important thing, I guess, one important thing to notice is that we're declaring our message in our constructor, and the reason for that is because I don't know at least of any way to pass command arguments into a command. We could, but it's probably not what we want to do from the view. We probably want to control what the message is going to say in the back end here in the view model, so that's why we're just going to go ahead and do it like this. Okay, and then once the command is executed, it's going to set our input to receive to hey, it works. In our setter, it will update input to receive along with the message display. So when we click the button, stuff should change. Now that's all well and great. We've exposed this property. We've set everything up. Let's go to our view and get to it. So we'll add a button, and we can actually just set the command property of this button and just bind right to the command. We're just going to go ahead, we're set some text that we don't lose our button on our UI here. Okay, there we go. So let's run this thing, and we'll type click me, and hey, it works. Not only that, but we've noticed that our text box, because it's bound to input to receive, is now updated with hey, it works. So we can type G, click this back, there we go. So you can see how you can have all sorts of different elements, and by setting it up properly, you can, when one thing changes, you can just cascade all of these changes all over your UI. And in fact, you can keep going and carry it over to your entire application if you do everything correctly. Okay, now we know that no presentation about code would be good without testing your code. Now of course you're supposed to test your code first, but for the purposes of demo we'll skip that. But if anybody asks you, I didn't. Okay, so we're going to go ahead, we're just going to go, actually let's go over the tests right now. I made two tests. The first test is the default message test, and this is just to test to make sure that when we first start everything up that the default values are what we expect, which is you didn't type anything. Now in order to simulate user input, all we have to do is just set some properties. So we're going to create our view model and then just set input to receive to this is a demo. And it will come up with the message you typed this is a demo. So we saw these run before, so we know that they're good. So let's add our next one here. So we'll copy and paste and modify. And we're going to say, let's make sure that the click command test. Let's make sure the click command works. So what we're going to do is we're going to, instead of setting the input to receive here, we're going to go to the click command, we're going to execute it with no parameter, just like the view would just automatically do. And we're going to just make sure that, we'll go back here, we'll just copy, and I guess paste it right here. Okay, and we're just going to run this. Boom, there we go. Success. So we can see that it's when we're making our tests, it's actually really easy to test our logic when we're using just view models. Now, like I said before, I mean our views are not really testable. But when you go into your view, you see there's not really much to test, is there? At the end of the day, we're just binding to exposed properties, which we can check the state of. And in fact, we can go ahead and we can do all sorts of great stuff in the view that won't break because, you know, at least it won't break just because, or based on user input, because everything's declarative. So it really helps to kind of make sure that you aren't mucking around with your view or your UI when you go ahead and try to unit test. Okay, so we've taken a look at MVVM, we've seen how it's done in Visual Studio, makes sense, really testable, love it. But now it's time to scale your application out. So you know, maybe you decide that MVVM is the way you want to go. So here's some tools that you should really check out. The first class of tools are MVVM frameworks. They're fairly specific, yes, but provide a lot of value and really make things easier. I've used MVVM Lite, and that's by a man named Laurent Bouillon. Now I'm not sure if I pronounced that. I'm sorry if I mispronounced that, but I saw him give a talk. Really great guy, knows his stuff. Made MVVM Lite, and I'm really digging this this particular tool. Basically, what it does is it helps you with view creation, view model creation, and then allows you to communicate in between view models. Allows you to make your application what he calls blendable, which means that you can actually just do all sorts of really neat stuff with design data in Blend. I mean, that's an entire topic on its own. As well, the practices and patterns team over at Microsoft put out Prism, which is they both have the same kind of core functionality, which is this idea of managing your views and your view models. I know that even MVVM Lite version 4, which I believe is in beta right now, has a simple ILC container that Loren implemented. Prism might not have that, so they kind of have these kind of outer, less used functions that are a little bit different, but the core of them is both the same. So ILC containers, like I said with MVVM Lite, you're probably going to end up with, like we saw, an ILC container to help create your view models, which can be a little difficult. So I've used Unity. I've heard Ninject is pretty good as well. As well, I always love to plug testing frameworks and unit testing in general. I love that stuff. So here's some unit testing frameworks that you might want to use. NUnit or XUnit. I've heard NUnit is pretty popular. There's lots of support for that. So remember to unit test. Okay, so we've just kind of studied MVVM from the .NET stack, right? But the MVVM is really becoming more popular. When I had first heard about it, you could really only find it with WPF. However, now you can find it all over the place, in different languages and in different places in your application as well. I mean, there's even MVVM for your UI and whatnot. So I've a quick Google search had given me ASP.NET and WinForms. Both of those have MVVM implementations on Codeplex. JavaScript has a library called Knockout.js, which basically allows you to do exactly what WPF does, which is subscribe to some data and then just say, hey, every time you refresh, let me know because I'm the one responsible for displaying you. I've even, I mentioned of Android as well. So I mean, it's really cross-platform, cross-language, all sorts of great stuff. It's just a pattern. Okay, well that's about it for today. So to conclude, iNotify property changed basically is what lets you do all your MVVM stuff in Silverlight, Windows Phone 7, WPF. So this whole data binding idea, that's how we kind of solve and make MVVM possible in the Microsoft stack. Your VM is going to expose properties. Your view consumes them. So that's how you want to kind of have that dynamic going between the two of them. As well as it's going to manage input. There's several frameworks and ILC containers, unit testing frameworks, all sorts of other stuff at your disposal for scaling out your MVVM application. And just remember that MVVM is more than just WPF. It's Silverlight, it's Windows Phone 7, it's Android, it's JavaScript. So, take this idea, hopefully you can kind of understand this idea and put that in your tool belt, and hopefully we can you can start to take some of the advantages and have them bleed over into the other areas of your development.